So for here, we're gonna introduce our logic for the p-pass. This is the front panel of our p-pass VI, and on the left, it's a desired curve. We're gonna draw the p there, and for the right side, it's an actual curve. The two duty cycles are constant, which is 30 thousandths, and we'll show the inside VI to show the logic. So for this VI, we used time to control the movement of the robot. From the beginning, we need the robot to go straight, so we set both wheel speed to 1, and then we have 5,000 milliseconds, which is by our experiment. It's got from our measurement. For next case, we make the two wheels stop for 500 milliseconds to see the movement, and then we have set the wheel speed, one wheel for full speed and the other wheel for 0, which makes the robot turn smoothly. And due to our experiment, the time takes about 300 milliseconds. And after this, we also need our robot go straight for another 3 feet. So we set the two wheel speed back to 1 and 1, and because the friction coefficient is now really constant, and by our experiment, by that section, it's going to take about 100 milliseconds, which is about 1 second. And for the next case, we need to make the robot turn a semicircle. Semicircle has the radius about 2.5 feet. To achieve this function, we calculate the width of the robot and figure out the path of the two wheels. Got the number for 1 and 0.8, which is how to make the robot turn a semicircle. And due to our measurement for the time, it took about 4,000 milliseconds to make the robot turn the 180 degrees. And after that, the robot should go back to the negative x-axis for 3 feet. So it also took about 1,000 milliseconds. And we took another pause because we need to figure out how long it's gonna turn. And we do the experiment. It took about 3 milliseconds. That's why we put those numbers here. And in the end, we make it go back for another 5 feet to complete the loop. And we set all the parameters to 0 in the end to stop this. So this is our logic for the circuit. It worked for 1 or 2 times, but it's really constrained by the friction coefficient and by the situation about the robot. It's not working perfectly, but it's like somehow functional.